Hello friends, welcome to another video from Alfie. In this video we are going to find ways to know if a number is a perfect cube or not in just a matter of seconds. Alright, now let's take a look at the numbers 1 to 20 and their cubes. So here are all the cubes of the numbers from 1 to 20, but I know it's not easy for us to remember them that easily because they get bigger and bigger exponentially, right? So we need to find some sort of a pattern in these cubes. All right, so here is something that may help you. If you notice, any number that ends in 1, its cube is always 1. So cube of 1 is 1, cube of 11 is 1331, which ends in 1. Similarly, cube of any number that ends in 4 is always 4. The cube of any number that ends in 6 is always 6. A cube of any number that ends in 9 is always 9. And a cube of number that ends in 0, of course, always ends in 0. And the cube of any number that ends in 5 always ends in 125, 325, 625, or 875. Okay, ultimately it also ends in 5 regardless. But if you look at 2 and 8, you may have seen the color coding there. It gets swapped or interchanged when you look at the cube. Any cube of a number that ends in 2 always ends in 8, and any cube of a number that ends in 8 always ends in 2. Okay, similarly, any cube of a number that ends in 3 always ends in 7, and any cube of a number that ends in 7 always ends in 3. So that is something that may be helpful for you to remember. Another thing that we want to look at is to look at digital roots. Now, a digital root of a number is nothing but the number that you get after you add any number after you add the digits of the number repeatedly until you get a number between 0 and 9. So for example, if you are trying to find the digital root of 4913, then it's nothing but you add up the digits, which gives you 17, and then you add up the digits of 17 again. 1 plus 7 gives you 8. So the digital root of 4913 becomes 8. Similarly, digital root of 729, you add up the digit, it gives you 18. You add up 18 again, and that gives you 9. So you need to know how to calculate the digital roots. Now that you know how to find out what a digital root is, we'll let you know what the pattern is now for perfect cubes. Now, if you look at these perfect cubes again, you will see that I've calculated the digital root for all of the cubes, and here you see a pattern, right? The digital root is 1 and then followed by 8 and 9. Again, 1, 8, 9, 1, 8, 9, 1, 8, 9. So you see that any perfect cube has a digital root of either 1 or 8 or 9. That's helpful, right? So it definitely helps when you're eliminating numbers, when you have multiple options. But again, digital root of perfect cubes are either 1 or 8 or 9, but that doesn't mean that if any number's digital root is 1 or 8 or 9, then it is a perfect cube. No, it does not mean that. But the converse is true. If any number is a perfect cube, then its digital root is, it has to be either 1 or 8 or 9, not the other way around. Okay, now let's look at an example. Here we have to find which of these numbers is a perfect cube. So what are we going to do? We are going to try to solve this by using the digital roots property that we just learned. Okay, so here we are going to look at what are the digital roots of all these numbers. So it turns out that the first number's digital root is 7, second number's is 9, third number has a digital root of 2, and the fourth number's digital root is 3. So immediately we know that The first, third, and fourth numbers are not perfect cubes because we already know that the digital root of perfect cubes always is either 1 or 8 or 9. So we have just eliminated the first number, the third number, and the fourth number by looking at their digital roots. So we are left with the second number, which is 13824. Now that we have 13824, we know that it may be a perfect cube, right? But since we've already been given that one of these numbers is a perfect cube, we know that this has to be a perfect cube, but it's always good to validate, right? And of course, by prime factorization, it seems that, okay, we got four triplets, so 3 triplets of 2 and 1 triplet of 3. So that means our guess was right. 13824 is definitely a perfect cube. Its cube root is 2 times 2 times 2 times 3, which is 24. But again, remember, if any number's digital root is 1 or 8 or 9, does not mean that it is a perfect cube. So this validation definitely helps. It helps to prove that, okay, what we just eliminated turns out that that option was indeed right. So like I said, digital roots help you eliminate the other choices and definitely helps you in solving multiple choice questions. Alright, so if you enjoyed this video, give your thumbs up and talk to you soon. Please subscribe to our channel too if you get some time. Thanks so much. Bye.